Hi-oh, here we are again. Lenses. First off, I want to show you something. I've drawn a prism. If we draw a ray of light coming into this prism, we know the light has to bend going from air into the glass, bend towards the normal. And of course, as it exits the glass, it has to bend away from the normal. Well, imagine taking two prisms and putting them together, and you would have the rays converging together, and this looks a lot like what's called a convex lens. Likewise, if we have two prisms that are point to point, the rays are not going to converge, they're going to diverge, and we would have what's called a diverging lens, or in other words, a concave lens. The two different lenses follow very similarly the rules of mirrors, except in an opposite way. Instead of reflecting, they let light through. Instead of a convex mirror causing light to spread apart or diverge, a convex lens causes it to converge, and so forth down the line. So we notice that in a convex lens, the light comes to a point or focus, and the concave one, they spread apart, so it's called diverging. And if you trace those back, we come and create a virtual focus. In each case, an easy trick to remember is the ray always bends towards the thicker part of the lens. The human eye itself sometimes needs some help. If the rays tend to focus in front of the retina is where we get the image produced, or where we want the image produced. If it rays in front, our eye is too long, so we say we're nearsighted. Someone who is nearsighted needs to take that focal point and make it go backwards. In order to do that, you need to spread those rays apart a little bit, and so we need a diverging lens to do that. Someone who is farsighted, the eye is short, and so the rays tend to focus behind the retina, and so we need to cause those rays to converge together a little bit. And so you use a converging lens or a convex lens. For ray diagramming, the rules of doing lenses are very similar to mirrors. With mirrors, we did PF and then FP. With lenses, it's PF, which is the first part of ray 1. So this is part 1. And then C, which is part 2. So in other words, a ray would come in, that's part 1, hits the lens, and then goes through, right? Lenses allow light to go through, and that would be part 2 of the ray. We'll show you what that means a little more, but remember that pattern. Just like mirrors, the point of intersection, except at F, of course, the rays, they come together, that's that part of the object's image. So if we take let's say, rays from a candle flame, from there we're going to find the image of that candle flame. Lastly, if they don't intersect, we have to do, as I suggested earlier, trace them backwards. Lenses are designed to let light through, and if they don't come to a focus, once they go through, they're on the other side. They essentially reflect. It's a virtual type of image. Okay, when drawing these ray diagrams, let's put an object somewhere past F. So this one will work from anywhere from F onward. We go parallel, right? The pattern was P then F. So P is parallel to the principal axis. We can go to this midline of the lens and then change directions. So then that was change directions and go through F. Remember, light goes through a lens. And we could, of course, draw the normal here and then have it change directions, draw the normal over here. It comes out to be the same exact place. So that was the first ray, PF. The second ray was C. And C in this case means go through the center. So we're going to go through right here, the very, very center of this lens. And of course, here we go. And our Where those cross is where our image is. Notice it's inverted. It is smaller. It is after C. And it's real. It's a real image. We could project this onto a screen. Notice, and you can probably see this is our object is a little bit in front of C. Well, our image is a little bit behind C. C is the break-even point. If it starts at C, it ends at C. If we put our object way back here, our image is going to be way up here. Oops, that should be upside down. So C is kind of that break-even point. Okay, what happens if our object is between the focal point? And realize these are if we're putting our objects on the left-hand side here, these are virtual focal points. They don't actually exist. And remember, C is the curvature, so in other words, this would be the center of this curve right here. Okay, first ray is PF, so parallel, hit the lens, and then do the focal point. Second one is through the center of the lens, which is right here, the very, very center. And notice those are not going to cross. So what do you have to do? You have to trace them backwards. So let's do that. I'm going to draw it dotted because they don't really exist. Of course, where they cross is where our image is located. There's our image. It's upright. It's larger. It's virtual. And it's on the same side of the lens as our object. Lastly, what happens if we have a concave lens? Now, it doesn't matter where you draw your image, because you'll get the same results where you draw your object. You'll get the same results every single time. Same rules apply. All right. PF is the first ray, so we go P. However, careful, this is what type of lens? Diverging lens. So the ray is going to go up like this. How do we know what angle? Well, it turns out if you trace it back to this virtual focal point, back here, I'll dot the ray back here so you can see it's lined up. If you trace it back to that virtual focal point, that's the angle at which it would go up. The second ray goes through the center of the lens, and looky there, it crosses right there. Notice the image is smaller, it's upright, it's virtual, it's between the object and the lens, and there you have it.